Okay, we'll go to the next algorithm, that is to insert an element. Now students normally have a confusion between insert an element and insertion sort. Please understand these are two different programs. Insert an element means you are going to insert a particular element in a particular list, and insertion is a sorting method. So there is a difference. So we are going to look into the next one is insert an element into an array. So first let us understand what this operation in an array means to us. So I'll give a fine example. You have an hostel and suddenly you find that there are floors from 0 to 3. That means someone is there in the ground floor, someone is there in the first floor, someone is there in the second floor, someone is there in the third floor, and the fourth floor is vacant, for example. And suddenly you find that a person joins and he wants to be there in the first floor. So what we are supposed to do? We are supposed to shift the person who's there in the third floor to the fourth floor, from the second floor to the third floor, and from the first floor to the second floor. And then we take that person and put down into first floor. Now this is a logic we need to adopt even here. Let us see with an example what we can do. So we have this array . Now these are the subscript index 0, 1, 2, 3, 4, 5, and A is the name of the array we are given. Now suppose we have these elements 5, 2, 8, 12, 10. So how many elements are there at present? It is 5. So what should be the value of n? N should be 5. Now next is we need to insert the element at a particular position. In the last example I mentioned you, in the first floor someone wants to go and stay. So let us have the position here, that is P. We'll take that P as a position. Let it be 1. It means I need to input the new element at this particular position. And the new value, that is the element we need to put down at this particular junction, will be, for example, 20. So what I need to do here, first, I need to shift this value to A of 5. So if I put down over here, how I'll write down? I'll say A of 5 is equals to A of 4. It means 10 will be shifted here. Now this 12 I'm going to shift to the above. So that means A of 4 is equals to A of 3. So 12 has been shifted here. The next one is this value I'm going to shift over here. So it means A of 3 is equals to A of 2. So what will be there in A of 3 now? 8. And the next one is A of 1 is equal, A of 2 is equals to A of 1. It means I've shifted down this 2 value up here. Now I have made a place for this element 20 to be stored here. So I can store this over here. This is how manually, we can see it works. Important for us is this part, this example. With this example, we can actually write down the program. Now, you can see here the subscript value, from which position it has started, from 5. I'm talking about the left hand side. Then it has gone to 4, then it has gone to 3, then it has gone to 2. It means if you take this part, I can say it travels from 5 to 2. It means the value of I should travel from 5 down to 2. It's coming down. The second one I can take down is this spot, where it travels from 4 to 1. 4 to 1. So you can see here 4, 3, 2, 1. Now it depends on you whether you want to have this or this. Please understand, both will work. Important is, if these are the elements, this is the position, you can see here how many times we are repeating this statement. It is 4 times. So you can check, this is 4 times. If you go by this is also 4 times. Now let us try to see whether I can put down this in the form of a program or as an algorithm. So we'll write down an algorithm for the same. If you're going to start from 4, now please see here what you can do here. So I can say here, for I is equals to, how I can get 4? N minus 1. What is the value of n? 5. 5 minus 1, that is 4, right? Down to 1, where you have stored 1 in P, down to P. So now it is very clear to you that how we can get this for loop. So we say for I equal to n minus 1, because I can go with the example. This will be n minus 1 to P. Now if this is I, the value of I is 4. So how I can get 5 here? It is I plus 1. So what can be the statement here? A of I plus 1. That is equals to A of I. This is a very important part of your algorithm. Very, very important. So you have the statement for I equal to n minus 1 down to P, A of I plus 1 is equals to A of I. Right? Now, what is so it means this should be my step 1. So once again look at the step 1. Step 1 is for I equal to n minus 1 down to P, and what you're doing when you're traveling from this floor to this floor, it means you are actually putting down this value over here. What should be the step 2? Step 2 has to be, what is the next step we have done? Immediately we have put down the element, where? In A of 1, that is A of P. So A of P is equals to the element you are going to put down. I feel this step is very clear to you now. We have pushed the element. Now suppose if you are going to add one more element. Initially you had 5 elements. How many more elements you are going to have? 1 more. So the value of n increases or increments by 1. So your step 3 has to be n is equals to n plus 1, and step 4, that is exit. So I just want you to go through the algorithm now, right? This is the algorithm to insert an element into an array. So I explained you everything, how exactly we need to do this. And please understand, I've taken this algorithm from the example I have set for you. So it becomes much easier. Even this I can go for. If I'm having this for loop, the for loop will start from for I equal to n down to how I can get to p minus 1. In this case, you'll have a of I is equals to a of I minus 1. So I can have this for loop, I can have this for loop, any one. But always you set an example so that your algorithm will be very clear to you what you're supposed to do when you want to insert an element. So these are the steps. Now I'm going to write down the program. Yeah, now this is a program that is to insert an element. Already we have worked with the algorithm. I've set an example for you. But very important is the condition. Now here, when you write a program, you need to ask the question whether you can insert an element. Now for example, we have a of 0, a of 1, a of 2, a of 3. Can we insert at a of 4? Yes. But is it possible for us to insert at a of 5? No. We cannot insert at a of 5. So it is telling you that if the value of p is greater than n, it means you cannot insert an element. So if you see what we have done earlier, and if you reflect it to the program, only one change we have done is, one addition we have done is, we have taken care of this part of the program. That is, I'm talking about this one. Let us see step by step what we have done. So these are the same things what you have done earlier, the number of elements you need to ask, then you need to input this for loop with the cin. A of I tells you to input the elements. The next part is you're asking which position. If you remember, we asked the user which position the user want to input the element. That is what we are storing it in P. The next part is which is that element you want to insert at that particular position. Now here the things start, the processing part. So the first thing you're asking the question whether p is greater than n. That means we are telling that if it is greater than n, I cannot insert any element. That's a rule. If it is not, that means the else part. So it's the same thing what we have done. Look at the algorithm. It says for I equal to n minus 1. That means we have started with n minus 1. If you go back to the algorithm, you will understand our n minus 1, the problem given was a of 4. So we started from there, until which point we have to go? Till p. And please understand, it goes from 4, 3, 2, 1, right? So look at the condition here, I is greater than or equal to p. That means it's going through the reverse side. And I minus minus, because it goes from 4, 3, 2, 1. It is same as you go to the mall. What you are going to do if you have to travel from 4th floor to the ground floor? It will be decremented. So you're going to decrement here, the counter, right? And what you have done, a of I plus 1 is equals to a of I. So this is what we have done in the for loop. Once you come out of the for loop, the first statement after the for loop is a of p is equals to element. If you see the second step in the algorithm is the same, a of p. That means you're putting down that particular student in the first floor, right? This is what we are doing here. We are putting this element at this particular position. Once that is over, we need to increment the value of n. That means earlier it was 5 elements, now it has become 6. So the number of elements have to be incremented. The last step is the same as what you have done earlier, that is to display the elements. I just want you to go through the program once again. Quickly, I'll let you know what we have done. We have inputted the number of elements. We have inputted the elements into an array, this part. Then we have asked for the position. Then we have asked which is the element you want to enter. We have checked for the condition. If it is greater than n, we cannot insert else. Now this is very important. Look at the else. This is the start of the else. This is the end of the else. So everything you do it in the else, right? So in that we have put down the values as we go down from 4th floor to the 1st floor, then put down the element into that particular position, increment the number of elements, and then display. So this is a program to insert an element into an array. So now we'll go into the next one, is to delete an element from an array. Now that is more simple actually. You just take the element out from there. So what we are going to do if we are going to delete? Let us see. To see is to delete an element from an array. The same procedure we are going to apply. We will see with an example. Now what the example will say, you're taking an hostel and someone from 1st floor wants to leave the hostel. What you're going to do, shift the person who is there from the 2nd floor to the 1st floor, from the 3rd floor to the 2nd floor, from the 4th floor to the 3rd floor. That is a procedure we apply. Let us see with an example what we can do. So we have an array here. Now for example, these are the elements 5, 8, 3, 4, 2. Now the first thing is, how many elements are there basically? What should be the value of n? So the value of n, again here I have taken it as 5. And I want to delete this particular element. So what is the position I am asking for the element to be deleted is 1. So here it becomes more simple for us. Directly, you can transfer this element from a of 2 to a of 1. So this becomes 3. Transfer this element over here. So this becomes 4. Transfer this element. So this becomes 2. Right? So now we can get the new set of elements, that is 5, 3, 4, 2. It means one element has been deleted. Earlier we had 5, 8, 3, 4, 2. We had 5 elements. Now how many elements we are having is 4. That means the number of elements we have decremented. In insert what happens? We have to increase it by 1. In delete, we have to decrement it by 1, the number of elements. So this is a procedure. Let us see with an example how we are going to do this basically. So what we have done, if you look at this, we have written a of 1 is equals to a of 2. A of 2 is equals to a of 3. That means I brought it down basically. Right? So a of 1, it was brought from a of 2. A of 2, it was brought from a of 3. A of 3 was brought from a of 4. Now this is what your index looks like. That is 1 to 3, or it may be from 2 to 4. Right? So now I can travel from here to this one, or maybe from here to, that is from 1 to 3, or maybe from 2 to 4. So how you are going to write down the algorithm for the same? So your step 1 will be for I is equals to, where is this 1 stored? In P. P to 3. How you are going to get 3? N minus 2. Now please understand, it is going from the lower range to the upper range. So from lower to upper. The earlier insert was from upper to the lower. Now if this is A of I, what should be this one? A of I plus 1. So you have A of I is equals to A of I plus 1. This is your first step. If you compare it with the insert, this was the first step. But the change in the loop and the out. Step 2. Now, step 2 can be n is equals to n minus 1. And step 3 can be exit. Now please understand, this is one way of writing down. Now, the element you are going to remove from here, I want to make use of that element in the future, then there will be slight change in this. Please understand this. Now, with this algorithm, it tells that I don't need the value 8. It's gone permanently. But suppose you need that, then there will be slight change in the algorithm. So what you can do here is, you can put down step 1 as item is equals to A of P. This can be your step 1. This can be your step 2, 3, and 4. Is that clear to you? If you are not using this value 8 anywhere down the line in your program, you don't need it, then the previous one would have been the best one because you don't need it. But suppose you need it, in that case, you need to have the first step as item is equals to A of P. That means what was there in A of P? What was there in A of P? A of 1, it was 8. So what you're storing it in item 8. Is that clear? Please go through the algorithm once again. It is item is equals to A of P. Then you have step 2 for I equal to P to n minus 2. A of I is equals to A of I plus 1. And then you're decrementing the number of elements and then you're exiting. Now we'll go for the program. Now this is a program to delete an element. Already we have seen the algorithm, we have seen the problem. Now very important was the problem manually we solved. From there we actually got this statement. That is important. Now the same thing, you have an array. I've taken the size as 20, I, n is for the number of elements, and p is the position I've taken. So the first part and the second part is almost the same as we have seen for many programs. So the first part is enter the number of elements. In that case, how many elements are there? We have around 4 elements, right? and then we enter the elements. We have entered those elements, that is 1, 2, 3, 4, using this for loop. Then we are asking which position you want to delete, right? Now, we had given the example earlier, we want to delete at the position 1. That means this element 2 can be deleted. Can we delete any element from this position? No, because we don't have it. So, if you have the value of n as 4, right? The value of n as 4. So that means I cannot delete any element if it is greater than n minus 1. So look at this condition. If p is greater than n minus 1, if I am giving p as greater than n minus 1, then is it possible for me to delete? No. Right? So I cannot delete. In short, I cannot, because nothing is there here to delete. So it says invalid position. I cannot do it. Else, this else will remain the same as what we have done earlier. You have the for loop which starts from p, I is less than n minus 1, I plus plus, right? And you are putting down the elements, that is a of I is equals to a of I plus 1. And this is again an important statement here, that is n equal to n minus 1. Why? Because we are decrementing the number of elements. So we have the statement n is equals to n minus 1, and finally we display. But we display one element short. That means we have reduced. This is how the program has to be written. But very important is the first part, where you mathematically have done it. And then we have moved towards the algorithm. And if we can understand those two steps, I feel this one will be much easier for us to understand. So I want you to just go through the program once again. You have the first part is the input the number of elements, then you're putting down the elements into an array one by one. You're asking for the position, which position I want to delete basically. Then you're asking the question, if it is greater than n minus 1, it is not possible for you to delete, else we are doing this step. In this step else, see this, again I'm repeating this is the start of the false, this is the end of the false. So this is the first part and this is the end. So here what we have done, we have transferred the elements from this position to this position. So it is very important that you again look back what we have done in the algorithm part. If that is clear, then writing down this becomes much easier for you, right? Then we have reduced the number of elements, and then we are finally displaying. Now please understand, instead of this statement n equal to n minus 1, I can even write down I is less than n minus 1. That will also be fine if you're not writing down this statement here. So we can put down the statement here, right? So please go through the program once again and try to understand. Otherwise, go back, look at the algorithm, and come back and just reflect with this program. It will be much easier for you to go through. And always keep a live example. As I mentioned, in the hostel, you delete, and then what you're going to do physically. And please understand, we cannot have two elements at the same time. This part also you need to understand when you're doing the things. I can store only one element at any particular time. So if you're putting the second element in that particular place, the first element is lost. If that you can understand, then the things will be much easier for you. Now we'll go to the next problem, that is insertion sort. I did mention to you earlier that we have a problem when the student, they take the word insertion, they get confused with the word insert. And I told you, insert an element and insertion sort, these are two different things. What is sorting? Actually arranging the elements in any order, whether it's ascending order or a descending order. So insertion sort is one of the method. You know, there are many methods used in the sorting. Insertion sort is one of the method. So let us see how actually the insertion sort works. That is important. Now when we take this, I've taken around 1, 2, 3, 4, 5, 6 values. So your value of n is 6. And what I do here is I divide this into two parts. I say this is a sorted and this is unsorted. This is a sorted list and this is unsorted. Why have taken this only one element as a sorted? Because we know that one element, so we don't need to sort. So this is already sorted. Now what we do here is, the first step is, that's the reason you can see that it travels, you have to travel from 1 to 5. That is n minus 1, 1 to n minus 1. So your outer loop basically has to be the number of passes, 1 to n minus 1. Now what is the step? What we do here is, we take the first element of the unsorted and then we place it in a variable called as temp. So what we are doing here is, we are just transferring this value to this particular variable. So now what this variable will consist of? 3. So it means this becomes empty. This becomes empty. Now next is, I compare this element 5 with 3. I compare 5 with 3. When I compare 5 with this value 3, I find that 5 is actually greater than 3. So what I do is, I shift this to the next position. So I shift this value to the next position. So here it will be 5. Right? Now how your array will look like, look at this. Your array will look like this way. That is, you have shifted this 5 here. So this will be 5, 10, 1, 6, 2. Now can you compare 3 with any more other value? No. So that was the last value. That is in a of 0. So I cannot go below a of 0. That is what it talks about. Now what I do here is, I transfer this over here. So the value is now 3, 5, 10, 1, 6, 2. Right? This is the value. So now what I have here is, the first part here is, this is sorted, this part, that means these two values, and these are unsorted. Right? Now the next step is, I take the next value. That means the first value in the unsorted. Same procedure. I put down into the box temp. So what is the new value? The new value in the temp will be 10. Right? If I am pushing this over here to the box temp, then what happens? This becomes empty. Right? Now see what I am going to do next. I am going to compare 5 and 10. Now when you compare 5 and 10, what you find? 5 is smaller. If 5 is smaller, that means this element is smaller than that. Do I need to shift towards the right side? No, there is no need. So what I need to do here now is put down this value here itself. So your new value will be 3, 5, 10, 1, 6 and 2. So look at this. So now this becomes a sorted list and this becomes unsorted, right? Now the same procedure you apply. First element of the unsorted, push it to the temp. So what will be the value here? 1. Now this becomes empty. Now this is very interesting because you are going to shift a lot. Now this 10 I need to compare with 1. Is it greater? Is it greater? Yes. So what I need to do is I need to shift 10 here. So 10 will be shifted here. So in fact how your array will look like somewhat in this way now. Look at this, 3, 5, this will be a 10, 6, 2, right? Isn't it? Because you have shifted it by 1 position. Now you compare 1 and 5. What happens? 5 is greater. So 5 has to be shifted to the next position. So this will be 5, 10, 6, 2. So this will be 3. So now the next is 1 and 3. So 3 is greater. So 3 will be shifted to the next. So this will be in this form. It will be 5, 10, 6. Do you have any element other than 3 to be compared with 1? No. So what we do is this value we put down over here. So this will be 1. So now we have 1, 3, 5, 10. That means this is a sorted list. This becomes your sorted list, right? The next value what we have here is the, in the temp you are going to have is 6. So that means this becomes empty. So this is a sorted now. This is unsorted. Is it fine? Yes. The same procedure. 6 will be compared with 10. So what happens? 10 is greater than 6. So 10 will be shifted, right? Then you compare 5 and 6. Since 5 is smaller, so what we do is we shift back 6. So I'll write down here. So your will be 1, 3, 5, 6, 10 and 2. This is what your array will look like. Now the last value is 2. So that means, please understand, this has become sorted and this is unsorted, right? The same procedure. Push 2, sorry, push 2 here. That means this is empty. 2 and 10, 10 will be shifted. 2 and 6, 6 will be shifted. 2 and 5, 5 will be shifted. 3 and 2, 3 will be shifted. It is shifting towards one position, towards the right. 1 and 2, no. So what we do is we put that 2 here. So your final array sorted one will be this form. So that is 1, 2, 3, 5, 6, and 10. So this is how we sort. So what we do is, we have reflected into the algorithm. Let us look into the algorithm and compare it. So look at the first step. For I equal to 1 to n minus 1, this is what I've been telling you right from the start. That means it has to go from 1 to n minus 1. Your outer loop has to be from 1 to n minus 1. What is the first step we have done? The first step we have done is, we have put down this value, a of I, that value. If you look at this, 3 was put down into temp. So the value of temp becomes a of I, right? Then, once you have done that, you are trying to compare with the next one. So, what is the next one? J is equals to I minus 1. That means J will start from this position. If you take the next one, it starts from here. If you take this one, it starts from here. So J will be here. If you take the next one, it will be one position lesser. So J is equals to I plus 1. This next part is, when you are going to shift the elements towards the right side, when the value of J is greater than or equal to 0 and A of J is greater than temp. Now, every time I used to ask you the question, for example, look at this. I was asking the question whether this value is greater than this. So the same question you are asking here. If A of J is greater than temp, if it is greater than temp, what we have done? We have moved this element, right? Where we have moved this element? Into J of 1. That means, when we compared 5 and 3, if this is J, where we have moved 5 to J plus 1. That is what we have written down here. A of J plus 1 is equals to A of J, right? Once I have shifted, then what I should do? I should still come down, because I is moving from 1 to 5 and J is moving in the reverse side, reverse direction. So the value of J has to be reduced. So J is equals to J minus 1. That ends your while loop, because this is what you are doing in the while loop. You are shifting it towards the right side by one position. Once you have finished everything, then you are transferring temp value where? Into A of J plus 1. Look at this first example itself. Once I've transferred this, I'm transferring this now over here. When I'm transferring over here, the value of J will be actually in the next position. So that's the reason we are writing down here, A of J plus 1 is equals to temp. And that ends your for loop. And the last step is the exit. I'll repeat this once again so that it will be clear. The same thing you need to put down into the program. The same steps. Only what will change is the input and the output. So I'll just repeat the steps. For I equal to 1 to n minus 1, what I'm doing here, the first step is temp is equals to A of I. That means I'm pushing the value towards the temp. Then the value of J, I'm setting the value of J where? One position lower than I. That means J is equals to I minus 1. So if this is your I, then J has to start from this position and move towards 0. That's the reason it will ask the question, J is greater than or equal to 0. That means anything below, it needs to stop. So then we have transferred the value into J of plus 1. What is this statement talking about? We are shifting it by one position towards the right side. We are shifting it. And then J will come down still, and finally, once everything is over, we transfer this value to the position where it has to be transferred. So that is A of j plus 1 is equals to temp. So that is important, right? Now I'm going to write down the program. Yes, this is a program. I've transferred everything in the form of the program now. You'll find almost everything is similar now. So this part is again to input the elements, and the next part is to input the elements into an array. And I have taken as a capital I and j so that you can understand the difference. So then again I equal to 0, I less than n, I plus plus. That means this is a place where we are going to travel. So this part is the input part. And now from here onwards, it's a processing. So this is what we have seen. Temp is equals to A of I. That means whatever is there in A of I, we are transferring it into temp. Then what we have done, we have given the position for j. The position for j will be 1 lesser than the I. So it starts from I minus 1. Then we have a condition. The condition says that j is j is greater than or equal to 0, and A of j is greater than temp. A of j is greater than temp. Now, when you're doing that, I told you, you're moving the element towards the right side. So that is what you're doing. So you're moving the element towards the right. So A of j, you're pushing it towards A of j plus 1. And finally, as I told you, j has to be reduced. I is moving from 1 to n minus 1, j is going down to 0. And finally, we are shifting what was there in the temp back to A of j plus 1. So this is the sorting process method. And then finally we come to the output of this, where we display the elements, sorted elements. So we can even write down the statement here, C out sorted elements are, right? And then you can display.